Good day, everyone. This report explores descriptive analysis with a focus on measures of variability, which quantify the spread or dispersion of data. Topic outlines. Number 1, introduction. Number 2, measures of central tendency. Number 3, measures of variability. Number 4, visualizing variability. Number 5, interpreting measures of variability in science research. Number 6, summary. Number 7, references. Let's now discuss the measures of variability. Introduction. It starts by defining what descriptive analysis is and why it's crucial in scientific research. It highlights the importance of understanding variability in data to correctly interpret research results. Examples for Class A 55, 60, 65, and 70, and Class B 50, 55, 60, 75, and 90. Both have a mean of 65, but Class B has greater variability with a range of 40 compared to Class A's range of 15. For the data sets A 10, 12, 14, and 16, and B 5, 10, 15, and 20. Both have a mean of 13, but B shows greater variability with a range of 15 compared to A range of 6. Second, measures of variability. This section dives into the key measure used to quantify variability in data. Range, the difference between the highest and lowest value, a simple measure but sensitive to extreme value outliers. Interquartile range, or IQR. The range of the middle 50% data less affected by outliers than the range. Variance, the average of squared deviation from the mean, indicating how spread of the data is. Standard deviation, the square root of variance representing the average distance of the data points from the mean. For example, range. If the tallest student in class is 180 cm and the shortest is 150 cm, the range is 30 cm. Interquartile range. For the data 10, 15, 20, 25, 30, 35, and 40, the IQR is 20. Quartile 1 equal 15, quartile 3 equal 35, IQR equal quartile 3 minus quartile 1. Variance. For the data 4, 8, 6, 10, the variance is 5. Standard deviation. For the data 2, 4, 6, 8, and 10, the standard deviation is approximately 2.83. Third, choosing the right measure. This section explains how to choose the appropriate measure of variability based on the characteristic of data and research objectives. For examples, for the data sets A 10, 12, 14, and 16, and B 5, 10, 15, and 20, both have a mean of 13, but B shows greater variability with a range of 15 compared to A's range of 6. If a dataset contains extreme outliers, example 5, 10, 15, 20, and 100, the IQR 10 is more reliable than the range 95, as the range is heavily influenced by the outliers. In a dataset of temperatures 20 degrees Celsius, 22 degrees Celsius, 24 degrees Celsius, and 26 degrees Celsius, the standard deviation is preferred over variance as it's expressed in the same units, Celsius, and is easier to interpret. Fourth, application in scientific research. It provides examples from various fields like biology and physiology to show how measures of variability are used and how they impact the interpretation of research results. For example, in a clinical trial testing a new drug, researchers use standard deviation to measure the variability in patients' blood pressure reduction, helping to determine whether the drug has consistent effects across different individuals. Fifth, interpreting variability in scientific research from data spread to meaningful conclusions. Interpreting measure of variability in science research involves understanding how this measure reflects the spread of data points, how the spread affects the reliability and significance of our findings, and how we can communicate the insight effectively. For example, in the plant growth study, the range of height was 30 centimeters. The variance was low. The standard deviation was 5 centimeters. The interquartile was 10 centimeters, and the coefficient of variation was 15%, indicating moderate variability in plant growth among the sample. 6. Summary. This final section summarizes the main point discussed in the presentation, reinforcing the significance of understanding variability for accurate data interpretation. It encouraged the audience to explore the topic further through additional resources. References. First, textbook. Statistics by James T. McCabe and Terry Sinsich. Second, online resource Khan Academy's Statistics and Probability course provides clear explanation example of this measure. Third, textbook Data Visualization, a Practical Introduction by Karen Healy. Fourth, online resource the website Data to Viz. Fifth, journal articles. You can find numerous examples of how this measure are used in scientific research by searching of specific topics in relevant journals. Example, Journal of Biological Chemistry for Biology, Physical Review Letters for Physics, American Sociological Review for Social Science. Thank you for being an awesome audience for us today. Good day, everyone. Good day, everyone.